Hi, this is Christian Posta. I'm the Global Field CTO at Solo.io, and this is part 2 in a series on AI agent identity and access management. In the first part, we looked at agents calling other agents over A to A, agents calling MCP servers, but then securing the underlying connectivity with agent identity based on SPIFFE and issuing and exchanging on behalf of tokens that represent the agent acting on behalf of a user. In this part 2, what we're going to do is take a closer look at how agent identity is issued and how that is used in access policies to bind the tokens that we use for on behalf of to the actual agent's identity, and in this case the transport. So let's get going. So in this demo, we are running our workloads in Kubernetes. I'll just make this a little bigger. All right, so we have our supply chain backend, which services the UI. We have our supply chain agent, and we have our market analysis agent. We also have a number of backend MCP servers that the market analysis agent can call. Now, we are running a technology called Istio Ambient Mesh. So if we come over here, where's this go here? Istio Ambient Mesh. Is that here we go here. So basically what Istio Ambient Mesh is a substrate part of the puzzle here that focuses only on issuing identity to workloads. And it issues identity by attesting those workloads and giving it a SPIFFE credential. So if you're unfamiliar, SPIFFE is a specification that defines how to encode workload identity and the process for getting that workload identity. So there's a few different implementations of SPIFFE. Spire is an open source option, but Istio Ambient Mesh is as well, and they both work well together. All right, so what we can see is in our workloads, in our cluster, when we make a call between agents. So let's do that. We'll come back here. We'll get rid of that. I'm gonna just say we'll make a call to our supply chain agent, and we see we get a response here. If we make a call to perform market analysis, so we can see this response doesn't have any market analysis data. If we ask it to perform a market analysis, we will get some of that information. If we come back here and look in the tracing dashboard, you can see a few seconds ago a number of spans following the path from supply chain backend all the way back into the MCP servers. But we can also take a look at Kiali, which is a UI that comes with Istio and works with Istio Ambient. And we can see the connectivity between the backend. We can see that it is, so we'll click on this right here. This traffic, as it goes through the backend, is being directed through a gateway. In this case, it is Agent Gateway. The supply chain backend doesn't even know about this, but it knows it's trying to communicate with the market analysis agent, and that this underlying zero trust substrate is issuing identity and establishing mutual TLS. So we can see that anytime the supply chain backend calls anything else, it will go through this this zero trust tunnel and be issued credentials for SPIFFE, and will have those on the transport. So, and I'm sure there's a lot of questions if some of you are new to these concepts, but please take a look at SPIFFE, take a look at Ambient Mesh to get more. But we can see under the covers here, if we go to the Istio namespace and actually look at our zero trust tunnel, the traffic does indeed, let's see, this looks like destination workload from our agent gateway, but we can also see right here, so supply chain backend with the source identity of SPIFFE, blah, 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 right here, supply chain backend is destined, in this case for the waypoint, but it'll end up going to the supply chain agent. But you can see that everything is based on this idea of an agent identity or a workload identity. Now this becomes very important because in our agent gateway, what we can do is write policies that say, yeah, you can, this is not it, you can communicate with the supply chain agent, but the identity, the workload identity, has to be the supply chain backend. Right, so supply chain agent can only be called by the supply chain backend. And there's some other policies checking the token. So that means in our, let's go take a look at our call here. So if we come over here and we make, let's get rid of this. So we'll just do the simple call from the backend to supply chain agent. We see we get a response here. Now, if we go take a look at that token, let's go into supply chain backend. Right. So we'll take a look at full screen. We'll wrap the screen, and we'll come up here and we'll see, we see some response data here, but we also see the token. Now, this is a demo, and we don't recommend logging these types of sensitive tokens. Let's take a look at the token. Right. So this is the on behalf of token. On behalf of this particular user, that's me, that I logged in. Here are some of the access that it has. Here is the subject. This is the actor. This is the actual agent. This is supply chain backend in this case. It's a workload. And we'll be calling the supply chain agent. Now, if this token was stolen, and as you can see in my example here, I'm logging it just to hand it out, so it's not ideal. But if this token was somehow stolen, and we come into another MCP or A2A client here, and I do Python, actually let's do jot token, like that, and then we do Python, we'll get into an A2A terminal, and I want to call the supply chain agent. All right, so I'm going to use the A2A protocol, and supply chain agent, actually, let's see, okay, service, supply chain agent is running on port 80, so that should be no problem. So if we come here and connect up to supply chain agent, default, right? And we're going to use jot authentication here, so we'll say yes. And we'll use the environment variable that we just specified. Great, now let's try to connect. We cannot. We get a 403 forbidden. So we somehow either stole or observed this token, sniffed it somehow, it leaked somehow into logs or wherever. And this token is a token that says that this agent can act on behalf of this user. But now when I try to connect up with this token, I'm denied because our policies say that the workload identity and the agent identity has to match what's in that on behalf of token. So these tokens cannot be replayed or taken and used by any other malicious agent. They're bound to the agent's identity. And like I said, in this case, where you're using the premise of agent identity, and this is SPIFFE. So that's part 2. So we've covered quite a bit in these first 2 parts. In the third part, what we're going to take a look at is, now we have an agent gateway in the call flow. And we can do access policies based on agent identity on behalf of semantics. This is the waypoint right here is where agent gateway sits. And what we want to do next is apply policy to the MCP servers. And so we'll take a look at MCP authentication authorization in part 3. Thanks.